Now, before we look at this problem here, I just want to say that this is like a physics-ish type of exercise. I'm more of the pure mathematics emphasis. So how certain am I that what I am about to say is correct? Let's say about 95%. So now here the goal is to find the angle that produces the maximum range. R is the range, V naught, initial velocity. Theta is the launch angle, and G has to do with the gravitational constant, which they say is constant. Now, as soon as they say the word maximum, I have two things in mind. Number one, I'm gonna find the derivative. Number two, I'm gonna set the derivative equal to 0, solve, and that's gonna be my optimal angle. So let's find the derivative of R with respect to theta. Because let's say that V and G are fixed, they're constant, but theta is a variable and R is the main function. So I would have dr d theta. And then notice that this here, that's just a constant. So that goes along for the ride. The square of the initial velocity. Now the derivative of sine is cosine. Carry your inner function, but then multiply by the derivative of the inner function, which is 4. And so let's see, so this is 4g times cosine of 4 theta. So this is the derivative. To find the maximum, you set the derivative equal to 0 and solve. I need to solve this equation for theta. Theta is the angle, that's the goal. So we must isolate it. So let's get rid of g. So I multiply both sides by g, which is not dangerous because g is non-zero, right? It's not 0, it's some number, who knows? So that's gone, that's still 0. So I have this here. And then I can divide by 4 v naught squared because it's just a non-zero number. So that's still just 0. Now I need theta alone. So what I can do is I can take the cosine inverse of both sides. Cosine inverse here, pardon the small notation. And then for the cosine inverse of 0, type that into your calculators. And we prefer that your calculator be set to radians. For fancy math like this, we tend to use radians more than degrees. And cosine inverse of 0, it should say pi over 2. And cosine inverse and cosine knock out, so it's just 4 theta. And divide by 4 or multiply by a quarter, equivalent operations. The optimal launch angle would be theta equals, and this looks like it's gonna be pi over 8 radians. Final answer.